Section 210.10 of the National Electrical Code, or NEC, addresses arc fault circuit interrupter, or FSI, protection. It's crucial to understand the specific requirements to ensure electrical safety and code compliance. The key is to differentiate between an outlet and a switch, as defined by the NEC. The code defines an outlet as a point on the wiring system at which current is taken to supply fixtures, lamps, or other devices. In simpler terms, an outlet is where you plug something in to draw electrical power. On the other hand, a switch is defined as a device for making, breaking, or changing the connections in an electric circuit. A switch controls the flow of electricity to a specific point or device, effectively turning it on or off. Section 210.10 specifically mandates arc fault protection for all outlets. This means that any point in the wiring system where you draw power for appliances, lamps, or other equipment must be protected by an FSI device. The purpose of arc fault protection is to detect dangerous electrical arcs, which can be a significant fire hazard. FSIs are designed to quickly interrupt the circuit when an arc is detected, preventing a fire from starting. Now, considering the definitions and the code requirement, it becomes clear that only receptacles, which are a type of outlet, need arc fault protection. Switches, because they are controlled devices and not points where power is drawn, do not require arc fault protection under Section 210.10. To further clarify, think of a standard wall receptacle. This is an outlet where you plug in your devices. It requires FSI protection. A light switch, however, controls the flow of electricity to a light fixture but is not itself a point where power is drawn. Therefore, it does not need FSI protection. It's important to note that while Section 210.10 specifically addresses arc fault protection for outlets, other sections of the NEC may have different requirements for specific types of circuits or locations. It's always best to consult the latest edition of the NEC and seek guidance from a qualified electrical inspector to ensure full compliance with all applicable codes and regulations. In summary, when it comes to arc fault protection under NEC Section 210.10, the focus is on outlets, specifically receptacles. Switches, as control devices, are not included in this requirement. Understanding this distinction is crucial for safe and code-compliant electrical installations. Firstly, it's essential to familiarize yourself with the definitions provided in Article 100 of the NEC. This article provides the fundamental definitions of terms used throughout the code. Secondly, pay close attention to the specific wording of Section 210.10. It clearly states that all outlets must be arc fault protected. Thirdly, remember that an outlet is a point where power is drawn, while a switch is a control device. This distinction is key to understanding the application of arc fault protection. Fourthly, always consult the latest edition of the NEC and seek guidance from a qualified electrical inspector to ensure compliance with all applicable codes and regulations. Fifthly, consider the practical implications of these requirements. FSIs are designed to protect against dangerous electrical arcs, which can be a significant fire hazard. By providing arc fault protection for outlets, you are significantly reducing the risk of electrical fires in your home or building. Sixthly, understand the limitations of arc fault protection. FSIs are not a substitute for proper wiring practices and other safety measures. It's essential to ensure that all electrical work is performed by qualified professionals and that all wiring is installed in accordance with the NEC. Seventhly, be aware of other NEC requirements that may apply to specific types of circuits or locations. For example, certain types of circuits may require ground fault circuit interrupter, or GFCI, protection in addition to arc fault protection. Eighthly, stay up to date with the latest changes and updates to the NEC. The NEC is revised and updated every 3 years, so it's important to stay informed of any changes that may affect your work. Ninthly, always prioritize safety when working with electricity. Electricity can be dangerous, so it's essential to take all necessary precautions to protect yourself and others. Tenthly, don't hesitate to ask for help when you need it. If you are unsure about any aspect of electrical work, seek guidance from a qualified electrician or electrical inspector. By following these guidelines, you can ensure that your electrical installations are safe, code compliant, and effective. Understanding the difference between outlets and switches, as defined by the NEC, is crucial for applying the correct safety measures. Always refer to the latest edition of the NEC for the most up-to-date information and requirements. Remember that electrical safety is paramount, and compliance with the NEC is essential for protecting lives and property. It is important to elaborate on the purpose and function of arc fault circuit interrupters, or RFCIs, to fully understand the importance of their application to outlets. RFCIs are advanced circuit breakers designed to detect the unique characteristics of electrical arcs, which are unintentional electrical discharges that can occur due to damaged wiring, loose connections, or other faults in the electrical system. These arcs generate heat and can quickly ignite nearby combustible materials, leading to a fire. Unlike traditional circuit breakers, which primarily protect against overloads and short circuits, RFCIs are specifically designed to detect and respond to the presence of these dangerous arcs. They do this by analyzing the electrical waveform for patterns that are indicative of arcing. When an arc is detected, the RFCI quickly trips the circuit, interrupting the flow of electricity and preventing the arc from escalating into a fire. There are two main types of RFCIs: branch/feeder RFCIs and outlet branch circuit RFCIs. Branch/feeder RFCIs are typically installed in the electrical panel and provide protection for the entire branch circuit. Outlet branch circuit RFCIs are installed at the outlet itself and provide protection for that specific outlet and any downstream wiring or devices. The NEC requires RFCI protection in many areas of the home, including bedrooms, living rooms, dining rooms, and other habitable spaces. This is because these areas are considered to be at higher risk of electrical fires due to the presence of flammable materials and the potential for damaged wiring or overloaded circuits. While RFCIs are highly effective at preventing electrical fires, it is important to remember that they are not a substitute for proper wiring practices and other safety measures. All electrical work should be performed by qualified professionals and should comply with the NEC. Additionally, it is important to regularly inspect electrical cords and wiring for damage and to avoid overloading circuits. To further understand the application of RFCI protection to outlets, it is helpful to consider some specific examples. For instance, a wall receptacle in a bedroom is an outlet that requires RFCI protection. This is because the receptacle is a point where power is drawn to supply lamps, chargers, and other devices, and it is located in an area where there is a high risk of electrical fires. Similarly, a receptacle in a living room or dining room would also require RFCI protection for the same reasons. On the other hand, a light switch that controls the flow of electricity to a light fixture does not require RFCI protection. This is because the switch is not a point where power is drawn, but rather a control device that regulates the flow of electricity to the fixture. However, it is important to note that some jurisdictions may have local amendments to the NEC that require RFCI protection in additional locations or for different types of circuits. It is always best to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. In addition to understanding the specific requirements for RFCI protection, it is also important to understand the proper installation and maintenance of RFCIs. RFCIs should be installed by qualified electricians and should be tested regularly to ensure that they are functioning properly. The NEC requires that RFCIs be tested monthly using the test button on the device. If the RFCI does not trip when the test button is pressed, it should be replaced immediately. It is also important to avoid overloading circuits protected by RFCIs. Overloading a circuit can cause the RFCI to trip frequently, which can be a nuisance. If you are frequently tripping RFCIs, you should consider reducing the load in the circuit or having an electrician inspect the wiring for any problems. In conclusion, understanding the requirements for arc fault protection is essential for ensuring electrical safety and compliance with the NEC. Section 210.10 of the NEC specifically mandates arc fault protection for all outlets, which are points on the wiring system where current is taken to supply fixtures, lamps, or other devices. Switches, as controlled devices, do not require arc fault protection under this section. By following the guidelines outlined in this explanation, you can ensure that your electrical installations are safe, code compliant, and effective at preventing electrical fires. And it is of the utmost importance to consult with the latest edition of the NEC and seek guidance from qualified electrical professionals whenever necessary.